So here's problem number 35 from section 4.3. It asks us to use specifically the second derivative test to find local extrema. So we start by taking the first derivative, 3x squared plus 6x, and we're going to set that first derivative equal to 0. So we can find the critical values for the function. Let's pull out a 3 and an x, and that leaves us x plus 2. So I'm seeing a critical value at 0 and a critical value at negative 2.
Wait,
Yes?
why?
Okay. The second derivative test says that if we find values where the function is equal to 0, where the derivative function is equal to 0, and if we look at the sign of the second derivative, we can tell whether it's a maximum or a minimum. So here are two places where y prime equals 0.
But I don't understand. Okay, if you put 0 plus, if you did 3 times 0, and then 0 plus 2, wouldn't it equal,
No,
equal 2?
no. If I put in 0 for x here, I get 0 times something is equal to 0.
Oh, okay.
And if I put negative 2 in here, I get this is 0 times something is equal to 0.
Okay, I got it.
All right, on to y double prime. Y double prime is equal to 6x plus 6.
Yeah.
Okay? Y double prime at 0 is equal to 6, which is greater than 0. Y double prime at negative 2 is equal to 6 times negative 2 plus 6, which is equal to negative 6, which is less than 0. So here's my summary. F of, bad notation, try that again, y of 0, which is equal to negative 2, is a local, let's see, the second derivative is greater than 0, local minimum, because f, no, not f, we don't have any f's here. Y prime of 0 is equal to 0, and y double prime of 0 is greater than 0. Let's do it again. Y of negative 2, which is what? Negative 8 plus 12 is positive 4 minus 2 is positive 2. So y of negative 2, which is equal to, is a local, and again, we look here at the second derivative, it's less than 0. That means it must be a local maximum, because y prime at negative 2 is equal to 0, and y double prime of negative 2 is less than 0. So that contains the answer to the question, and it contains the answer to the explain or justify or show your work. Are we good there?
Yeah.
All right.